The first question of the week is to revise Chapter 1, Electrostatics. Okay, the question is Figure 1.7 shows two charges, Q1 and Q2. Okay, so we have Q1 is negative 3.2 times 10 to minus 6 and Q2 is 4.8 times 10 to minus 6 coulomb. Okay, they are separated by 4 cm. At position P, we have position P here. Okay, first is to sketch the electric field. So remember, we have electric field is symbolized as E. Okay, so electric field must be drawn at position P, and this electric field is due Q1 and also Q2. Okay, so to do the sketching, we have a negative charge here for the first charge Q1. So negative means that from point P, the electric field will be going inwards. So this is labeled as E1 as we have Q1 here. And then for Q2, it is positive. So from this charge, from this positive charge, it will be going outward. Okay, the direction is outward. So you can label it as E2. Okay, so that's for the first question. So if we draw it back here, your answer will be at point P, you'll have E1 here and also E2 here. So the label of your vector is compulsory so that examiners will know which one for which. For B, we have to calculate the electric potential. So the symbol is V. Okay, electric potential at point P. Okay, so let us write down the equation first. Vp is equal to V due to charge number 1 plus V due to charge number 2. So we have K Q1 over R1. So R1 here is the distance from R1, charge number 1, to point P, and K Q2 over R2 to point P. Okay, so we'll continue here as we have limited space. So our is equal to K is 9 times 10 to 9. You can factorize K. Okay, and your Q1 is negative. You need to include negative 3.2 times 10 to minus 6. Okay, plus Q2 is 4.8 times 10 to minus 6. So this is R1P is 3 cm. So R2P is here. Okay, this is our R2P. R2P, here is R1P. So we don't have the information for R2P, but we know here is theorem Pythagoras 3, 4, and here supposed to be 5 cm. Okay, or mathematically you can prove it using theorem Pythagoras. So R2P is square root 3 squared plus 4 squared. Then you're supposed to have 5 cm. Okay, so go back to the equation. Then this is here supposed to be 5. Okay, remember we're supposed to use SI unit, negative 2 times negative 2. Then you'll get the answer as negative 9.6 times 10 to 3 volt.